This video will show you the basics of how to set up Studio 5000 project with digital input and output cards, analog input and output cards, and some very basic control. So the first thing you're going to want to do is open up your Studio 5000 and click on New Project. Find the controller that you're using in your project. This will be the controller that you're going to want to be downloading the software into. So I'm going to be using the Compact Logic's controller, which is a 5069L330ER, and you're going to want to give it a name. So I'm just going to call this Basic Setup Project, and I'm going to change its location to where I'm saving it into a new folder, and then click Next on that. And then this is where you'll want to choose the revision. So depending on what version you want the software in, or your client is wanting the software in, you'll choose that from here. I'm going to go 34 on this one, and then you can add security if you need to, and then you've got a couple of different options for your security in there. And I click Finish. Okay, so the first thing you're going to see is a basic setup in your Studio 5000 with a main program and a main routine. I'm not actually going to put anything in there in this tutorial, but I'm going to add a new program to put our digital I/O buffers. But first of all, we're going to want to go to the tree and add ourselves a new module and put all our I/O in. So for this tutorial, I'm going to put in a digital input card, an analog input card, digital output card, and an analog output card. So if I type in 16 point, because I want a 16 point digital input card, I can just start typing and it'll bring up everything that's got 16 points in it. However, most of the time I'll use the show filters section, and you can basically see all the different things in there, and it'll just narrow it down to make it a lot easier. So I'm just going to unselect everything and select the Rockwell Automation Allen Bradley I/O, and I want it to be digital I/O. So I'm looking for an IB16. So I'm going to add that in there. So here you want to give it a name. So I'll usually call it what rack it's on. So this will be rack 0 because it's the local rack, and slot 1 because it's that first slot, but I can change that below. With the series and the revision, you'll want to have a look at the side of the input card and just make sure that this lines up and it matches correctly. I'm not going to put a description, but you can change the slot if it ever needs changing, just in there. So if you go through this, device information only comes up once you're online to your PLC. And I'm going to just click Inhibit Module because I'm not actually going to go online to this currently. I'll only uninhibit it once I'm downloading to the PLC hardware. And then if you go into your points again, just gives you some information in there that you can change if required, but I usually just leave all that as just standard. So that's our digital input card added. So I'm going to now search for the analog input card, which is IF8, which is 8-channel analog input card that I'm going to use. Again, on this, just make sure that your series and revision matches what is actually on the side of the card, because otherwise it can cause issues if those don't match correctly. And again, I just leave these as the standard settings. So again, just going to call this rack 0 slot 2 because this is our second slot. And okay that. Just inhibiting that again. So on the channels, you can see it's currently set to 0 to 20 milliamps and current. That can be changed to voltage. I'm just going to click OK on that. So now I'm going to look for the digital output card. So I'm going to use the 8-point card and click create on that. And again, check on the side of the card, make sure that the revisions match. That's rack 0 slot 3. Again, you can change things where required. So for here, you've got different modes. So if the PLC was to fault or go into failure, you can select what you want your output to do. So if you had something that needed to be failed in a safe manner, you might want to hold one of the outputs on. And same for program mode. This is be where you'd set that. But I'm just going to leave this how it is currently. When you're online, you can use the diagnostics button at the end there, and that'll bring up information and it'll tell you if there's anything slightly wrong with your card or any connections that you've got. Okay, so now I'm going to look for my analog output card. So OF4, so I'm just going to have a 4-channel output card. Again, this would depend on your application as to how many points you'd need for depending on how many you need for the site you're on or whatever the client is requesting. Again, let's call this rack 0 slot 4. You can call this whatever you'd like. I just find this is useful for me, so when I look in my tags, I know exactly where it is located. So again, channels, again, if it fails or you're in program mode, you can select this here as to what you want it to do. You can also change your engineering units in here. These are currently just set to 0 to 100% on the high engineering and low engineering, but that can be changed to whatever your application is. So if we have a look in the controller tags here, we can see all of the new tags that have been created. There are local slot for the PLC. So you can see that 1I, that relates to our local slot 1, and that's our digital input cards. You can see all 16 there, 0 to 15. And if we go into one of the points, it's the dot data, which is the data point you'll need for your PLC work and buffering any digital inputs too. Likewise with local slot 2, you can see in the rack that's our analog input card, and we can see when we go into one of the points again, it's the dot data that we'll need, but there are other information that you can get when you click into those. And then you can see there 3 is our digital output card. So we're going to go for the O on this one for local slot 3O, and then you can see the data. That's our data pointer that we'll be pointing our IO to for commands. Then 4, which is our analog output card. Again, that's our 4 channels 0 to 3 and data there. So if you've got anything for like a speed of a pump that you need to command and send over that's hardwired, that's where you'd use that. So I'm just going to add a new program in. It'll be for our I/O buffers. And okay that. So you can see that's created the parameters and local tags area, but we now need to add a routine. So I'm click new routine and I'm going to call this main. So all of your programs, you need to have a main routine. Basically, these will be this is the first point of what gets called first in your program, and then this can structure then what gets called next after that. So I've made the main, and then I'm just going to add a new routine. I'm going to call this A01 underscore DI underscore back 01 slot 1. So just so that matches with the name I've given the actual card in the hardware tree. And I'm just going to put in the description, this is a digital inputs. Okay, going to add a new routine now for our second card, which is our analog input card. So I'm going to call it B01. I usually go up in A. So if I had another digital input card, for example, that followed on from the last one, I'd have A02. So then it just keeps all of my everything ordered nicely. But because this is different, it's not a digital, it's an analog. I'm going to go on to B, call it B01. You can reorder these in the program itself, but I just like to have them so I know that it's always going to be in the correct order. So C01 for our digital output card. And then our last one is D01. It's our analog output card. So now we've got our program and routine set up for our I/O buffers. The routines we've just made, we need to call them in our main routine. So at the top, you can click through and see all the different blocks for anything you need. So you've got like timers, you've got counters, different types of timers, different type of counters. You've also got message instructions, you've got your maths, so you can have divide, multiply, subtract, and so on, or new rungs. But I know that what I need is called a JSR, which is jump to subroutine. So if I just type that in, it comes up, I press enter, and then all I need to do is drag my first routine into there, and that'll get called first. So when that main routine gets executed by the PLC, it'll then call that first one, and then the second one. Now I've added the JSR to that, and then I'll do the same for the other two. This is always a common thing when you're starting out that you might forget and wonder why your code isn't being called and it's not doing anything. Always check that you've got your JSRs in place to call your routines in your program. Okay, so now that's done, you can forget about that, and we'll add in the digital input buffers. So we're going to want an open contact and an energized output. And this is where we're going to want the data points from the local I/O, so from the card. So we'll have a look for our first one, which is local 1, and then I because it's an input card. So I'm going to just copy the data point of the first one. And I'm going to paste that in there. You'll notice that it's red and has a cross on it. That just means that there's something not right with that, and in that condition it would be an error, and you wouldn't be able to download to your PLC. So now I'm just going to put an output. I'm just going to have a pump start digital input. So this will be the feedback once the pump's running. the pump will then now tell me I've started. So I'll just call that pump start. And you can see it's still red because I've not created that pump start tag. See, it says undefined when you hover over it. So I'm going to right click and go new. And then you can change the usage, but those can stay the same. You've got different types of data type. So we're just going to have it as a bool, but you can have like reals that we'll see later, integers, double integers, the scope. So that's currently just getting saved in the parameters and local tags for the program. But I'm going to want it in the controller tags so that it's in the PLC and every other program is able to have access to it. And also, if you've got a HMI or a SCADA system, you'll want to change this to the controller scope. And I'm just going to give it a brief description here. Start command. Now all of my digital inputs and anything coming direct from the card, I like to put a prefix just so I know exactly where it's coming from and it's directly from the card. So I'm going to just put PLCDI bit, click create, and you can see the cross is gone. So it's now happy with that run. So I'm just going to copy and paste the second run. So on my second run, I'm just going to have it exactly the same. So if there's any digital inputs you haven't got, you want all, on this card it's a 16 point card, so you'll want to create all 16 bits, so 0 to 15. And even if you haven't got an output, so I have pump start on my first one, which is bit 0, you'll want to still put these in and just link them to themselves. So you'll see I'm changing all of these, so it's got them all in. And then once I've done that, I'll drag them across to the other side so that they just are there ready for if any inputs are added in the future. So I'm just going to drag them all across so that they are linked only to themselves. Okay, so I'm just going to save that. So that's our first digital input card set up. So you've got the point coming in, which gets energized from the hardwired digital input, and that then will turn on your pump start bit in the PLC. And that's basically your feedback of your pump saying it's running. So now onto the analog inputs. You're going to want to find a move instruction or type in MOV and click enter. Again, so we're looking now for local slot 2, which is our input card. We've got our 8 points there. I'm just going to find again the first one, copy that, paste it into the move instruction. Again, I'm just going to loop them into themselves. And then just update the channels to be the correct ones, so 0 to 7. Okay, so on the first one, again, these are input cards, so it's data coming into us. So on the destination bit, I'm going to have this as a tank level. And again, you can see we've got the cross, so we need to create that tag. And you can see when you verify either your routine, which will just search through that routine, or you can verify the full controller, and that will tell you if you've got any errors anywhere. So I'm just going to create my tank level tag. So I'm going to change my dint to a real. So I'm just going to start typing real. And I've still got it in the controller scope. So once that's been changed once, it'll stay there. But there are situations where you'll want to put the tags into their own programs, parameters, and local tags. But for now, I'm just going to put everything into the controller tags for this tutorial. So I've added my tank in there, and that's now healthy. So you can see my new tags have appeared now in the tag list. My descriptions are in there, but I've forgotten to put in front of my tank level PLC AI word. So you can do that in the controller tags by just clicking into them, and then you click enter and it'll change that there. So now we're going to set up the digital outputs. So again, we need an open contact and an energized output. And on this one, we are local 3 and O because it's our output. So I'm just going to find the data point again, copy that. And because these are outputs, they need to be on the right hand side for the energized outputs because we're commanding that point to turn on or off. Whereas with the digital inputs, those are coming into us, so our tags would be on the right hand side. Whereas with these outputs, our tags will now be on the left hand side. Okay, so now I've got those ready. I'm going to have an output command to my pump. I'm going to call that pump run command. And again, it's red and errored. So I'm just going to create the tag, put a description in, PLC deorbit, and pump run command, and create. Just going to save that. So that's going to our first point of our digital output card. But in the PLC, it's 0.0. So now for our analog output, copy the data point again. And here we'll need a move. So for my analog outputs, I'm going to have a speed command that gets sent to the pump. So I'm just going to call this pump speed. And again, different to the analog inputs, the tag will want to be in the source of the move instruction because this is an output going through the output card, and our tag is on the top, which was the opposite way around for our analog inputs. And again, I'm going to change my dint to a real so it matches what the card's set up for. And now that's created, we've got all our digital inputs, digital outputs, analog inputs and analog outputs all set up now. And our program tags also created. So I'm going to create a new program. I'm just going to call this pump control. I'm just going to add my main routine again. I'm going to call it main. And then I'm going to add another one, which will have our process code in it. I'm going to call it pump control again. And let's not forget to put in a JSR to call our new routine. So I'm just going to add that in there. And I'm just going to go into properties and change the name because I forgot to put my 801 in front of it, just to keep everything standard and everything to match, because it's good practice throughout your programs. And I'm just going to open this up. So I'm going to write in my process code. So I'm going to do a compare for when the tank level is greater than a value to start the pump. So I'll get my tank level tag, and I'm just going to add that to the greater than block. And I'll put if it's greater than 5.2 and an output to find my pump start command is not the pump start, it's the command there. So now when the level gets greater than 5.2, it'll start the pump run command, which will send the digital output to the pump to start. And then I'm going to add in a move instruction to tell it what speed to go at. I'm going to find my pump speed tag, copy that. And when my pump's being commanded to run, it'll tell the pump to run at 75%. And then I need another one to say when it is not told to run, to tell the pump to be at 0 for its speed. So I've got a normally closed contact, and you can see that's lit up green because that's currently the true value because our run command is not on. And I'm going to just put a 0 in there for the speed command request. And you can add yourself some run comments throughout your code so that if yourself or anyone in the future wants to understand what's happening on each of the rungs, you can put in a bit of a description in there. So I'm just going to put when the level is greater than 5.2, start the pump at 75%. And you can click out of there, and now it'll stay there. And it's always good practice to have that. Just helps give yourself, if you were to look back at a project you're working on, some information on it, or if someone else was looking at it. I'm just going to press save. So that's the end of this tutorial. I hope you found it helpful and worthwhile. I'll add another video and show you how you are able to emulate this. So if you didn't have the PLC hardware, you could actually run your process code. Thanks for watching and subscribe for more tutorials.